I had the lucky chance to open the, the Congress yesterday morning, and I had a chance to do a keynote in the ZSM workshop yesterday afternoon, and now I'm here kind of closing out the morning session this morning. And so part of the challenge for me is to try to bring some new insight every time I get in front of the audience. And I do have some new insights. I do have a bit of a recap of some of the things that I did show yesterday in the two sessions that I talked in. And I was also very interested to see the BT presentation this morning by Maria, because I looked at that and went, wow, that's pretty much what I've been saying for the last couple of years. That is the way we need to go. And I know that for my perspective, studying cloud services and AI, to me it was felt obvious that in some sense, if we look at back over the last 5 to 10 years, the cloud service providers like Google and Amazon in some way leapfrogged in terms of providing infrastructure as a service and created a new class of services we never had before. And the traditional communication service providers got left a bit behind. However, the last 2 years, I've been talking about something called the multi-cloud. Maria talked about cloud of clouds, and I've been saying it's a new chance for the communications service providers to get back in the game. And BT has obviously figured that out. I'm happy to see that. Many others have as well. And then with 5G, not only is it a chance for the communication service providers to get back in the game, it's actually a chance for them to take ground, because the cloud service providers probably aren't going to own the last mile. And when we look at the need for low latency and all the other requirements, it's a new game. It's a new day. But to get there, it's going to take automation. And part of what I want to talk about a little bit today is share with you some data that we have from the surveys I do of enterprises and how they've been building their multi-clouds. Because I actually think the communication service providers have just started the journey to build their own multi-clouds. And what that means is that if you take the traditional approach of thinking, if I need so many spec-ints of compute power and I get so many spec-ints per server, I divide the two numbers, I give you an equation, and that's how many servers as a communication service provider I'm going to buy. And I hope you don't do that. For those that are here in the room, I hope you look at a different approach where whatever part of the compute you need from going forward that you go and get it on demand from a Google or an Amazon instead of building it all yourself. That's part of what I wanted to highlight as I started this off. Now I'll jump into the presentation itself and try to give you a bit more evidence as to why I think that's a smart thing to do. And I'm not saying that it should be all in someone else's cloud either. I'm saying there are differences, recognize them, but understand what you can leverage from, and perhaps follow some of what the enterprises have done over the last 10 years in terms of moving to the cloud and leveraging the ability to rent versus buy. And so with that, let's take a look at what I had put together originally. And I'm going to start off with a slide that's the third time I'm putting up this slide. So I'm going to go through it rather quickly. But just to make the point that it all started with SDN and NFV. And then we talked about needing to simplify networks, and we saw that through a number of examples today. Was a key enabler for automation. So I think that's borne out. I'm not the only person that said that. I've heard it countless times in the last 2 days. And that part of the way we want to automate is move towards zero touch. So that brings in the work at the ETSI ZSM committee. That brings in the work of closed loop automation. And we've had a discussion whether it has to be all closed loop or partially closed loop. I think that's open for interpretation. And then digital transformation is where we want to get to, getting to the digital communications service provider or digital service provider. Oh, okay, I don't seem to have the right presentation. Maybe I made a mistake, but I can. Why don't you go back to the PDF? We'll live with. It's probably going to be better than this one. I apologize for that. I'll talk to this a little bit. So this was a draft that somehow got through into the system. But what I wanted to share with everyone was, and this is a survey that we did of service providers. So this is our service provider survey. It's the one that says day 2, where we asked them, what are the key technologies that are going to help you go to a digital transformation? And yeah, okay, at least I'm on the right charts now. So we asked them, what are the key technology enablers that are going to enable the digital transformation as a service provider? And 88% of service providers surveyed said big data analytics. Not too much surprise, but that's on the top, followed by the cloud. So leveraging the cloud is what they want to do. That's what we're being told. And SDN comes right after that. Even though we've been talking about SDN for 5 years, no one's given up on it. We still understand it's very important. NFV right after that. And then machine learning and AI are under that. So that's interesting because we still have a lot of hype around it, but when surveyed, the service providers realize that there's an ordering that's important here. And then we have a lot of hype about network slicing, and yet that's way down the list in terms of what's going to do the digital transformation. So just something to keep in mind when we order thoughts and how we put emphasis on things. I had showed this a couple of times already, so I'm not going to spend a lot of time here. This was again asking the question, what are the challenges to automation? And we can see going from concerns about difficulty to not being ready, the technology not being ready, cost, and don't trust automation. So I've already presented this. This is just to recap. And then the architecture for automation, we talked about this as well. Now here, unfortunately, my build's not going to work because it's a PDF. But one of the important things I wanted to show you here is that we do have the feedback loop against all the domains. We've had a lot of discussion the last 2 days whether there's an Uber controller or not. I think there's going to be different ways that that's going to be realized. Not one size is going to fit all. But the important thing here is intent. And yes, I did hear it often here, which I'm very happy. The understanding that intent is a language in which you express what you want and how it should get done at a suitable level of abstraction that you don't have to be a network expert to ask about it. So that was well understood in the conference. And what I wanted to show here on this one is when we introduce AI, Maria also had the concept about needing localized loops to deal with certain domains, and we have that here too, in terms of the localized loops. So I think that came out pretty strongly and is very important in terms of how we're going to get closed loop automation done. And I asked also service providers, what are the network domains where they think they're going to introduce AI and ML? So the top one was in how they offer cloud services to end customers. And that could be connecting to multi-cloud. It doesn't mean that they're offering their own infrastructure as a services. That 44% said they want to do it in the carrier network for operations and management. 36% said in the back end, or integrating the optical and transport. And 32% said for security, which I think is a little too low. I hope that will come up. And I'm very sure this one's way too low, the marketing and sales part. In fact, what I'm going to show you in a little while is some of the most recent advances and the pre-built libraries that are available for leverage from the cloud service providers are all about image recognition, facial recognition, human interfaces, and the opportunity to use those to create a different kind of customer experience is something that I think should be way higher on the list than it is. So I'm going to challenge everyone in the room, rethink how you can leverage those modules. Think about a customer experience where in a natural language, instead of some GUI, I have to go in as a customer and ask for what I want, get my VPN service changed around. Okay, so coming back to where we can do a bit of reuse. So this is my multi-cloud chart. Looks a little different than Maria's, but it's a similar concept in the sense that the enterprises have started working on building their multi-cloud a couple of years ago. They're well down the path. On average, when we surveyed enterprises, we asked them, on average, how many different cloud service providers are you using? They already told us this year, in 2018, 10. 10 for infrastructure, and more for SaaS. So they're well down the road of going to different providers. It could be Salesforce.com, it could be Office 365, it could be Google because they like TensorFlow and want to use TPUs for execution of some of their algorithms. It could be because they prefer FPGAs and they want to go to Microsoft Azure for that, which you can get instances of that. And so it really is the diversity of compute that they need to do and the specific pre-built components that they want to leverage that are driving the diversity in demand. So a very good strategy for communication service providers to potentially provide their own local infrastructure as a service services, but augment that by seamless connectivity to the cloud service providers. Just to give you an example, I asked, this is a survey now of enterprises. So I've slipped in to provide some information or share some of what's been going on in the enterprise side for quite a number of years, and I think there's a lot of parallels. So the other thing that I would share with you is not one cloud service architecture fits everything the enterprises are wanting to do, and they're using many. So yes, about 55% of the enterprises that responded to this survey said they are using public cloud. Public cloud means a shared infrastructure that they rent a piece of, that they share alongside of someone else's infrastructure. Here, 50% said they're using private cloud. This does not mean on-premise. That's private cloud in a third-party data center where they're getting a slice of a data center that's not shared. So that's why I don't use the term public and private interchangeably, as some people try to do between on-prem and off-prem. That's not really accurate. Hybrid cloud, well, for us that is some part not shared, some part shared, where workloads can be dynamically moved between them. So it's fully managed. It's not just a piece here and a piece there. That's not a true hybrid cloud. The other thing is, hybrid cloud doesn't mean part on-prem and part off-prem. I can go to a cloud service provider and I can get both slices in their data center with bursting between the two. So just keep that in mind. It's an architecture. It's not telling you exactly how it's realized. And of course, they're well on their multi-cloud journey as well, some of the respondents. And some of them did make the journey going here, here, and here, and some don't. So I would come back to the statement I said at the beginning of my talk, that I think communication service providers and how they handle all their computational requirements should consider these architectures and shouldn't start off with the premise that all the servers they're going to buy and use are going to be ones they own and are on their own prem. Okay, then the next thing I wanted to talk a little bit about is, and I showed this briefly, I flashed it up twice, but I didn't have much time to talk about it. And today I actually have a little more time to focus on it. So I went to 4 different cloud service providers, the top 4 by market share: Amazon, Google, Azure from Microsoft, and IBM Cloud. Doesn't matter which slide I keep up. I actually went to look at what kind of data analytics they offer and what I would consider more traditional AI that they offer. And pretty much I found a similar set of services in all four. There are slight variants, but similar services in all four. And what I wanted to share with you is what type they were. So they all offered some sort of data lake, some sort of repository. They all offered some sort of pre-built capabilities to do correlation on large data sets, Hadoop architectures. They all had that. So I would say, as a communication service provider, getting started down the path of AI, maybe you don't have to build it all from scratch. Or at least you can start here, learn, and then decide what you want to build, which, by the way, is what many of the enterprises have done. People may not be aware is that a lot of enterprises started in the public cloud with shared infrastructure, and when they got to a certain scale, they actually found for certain things it's cheaper and better for them to run it on-prem, and they migrated back on-prem. And then they burst into the cloud when they needed that extra capacity. So it's really not a single straight line journey that I think the communication service providers are getting started on. Then we look at some of the AI offerings. And by the way, AI's been around for 30 years. As Dan said, when I first started to do my research, I was doing AI. I worked with some of the first neural network simulators. And most people already know that one of the reasons AI took 30 years is we didn't have the large data sets and we didn't have the compute power it was going to take to make it real. But that wasn't the only, and then we also had many, many ways to do machine learning. Neural networks is just one of them. And most of those ways of doing them, be it fuzzy logic that we heard talked about yesterday, which when I was a PhD student had just come on the scene, and all of a sudden we could reason about not only binary 0 and 1, we could do reasoning approximations, and there are many other models for speech recognition, Markov models, and things like that. The big advancement that happened with the Google Brain project, I think, was that one of the first ones was to relook at the architecture of neural networks and build them with many more layers than we had in the past, because we could, now that we had the capability to do parallel compute using GPUs and specialized silicon. And that, all of a sudden, made the technology that was around for 30 years powerful enough that it could start to compete with the human capability of computation. And neural networks, for those of you that don't know what they are, just think of it, they really model computation after how the human brain computes. So it makes them very good pattern matchers, which is what our brains are. We're extremely good at pattern matching, whereas we're not so good necessarily at numerical computation. And so we see here ML Studio, we have SageMaker from Amazon on the previous chart. That is the hardcore neural network related AI factory, where you could go there today, one of your technicians could learn to build a model and get started with neural network-based AI or other forms of machine learning. We have some of the very ones I talked about: computer vision, speech, sentiment recognition, image recognition, streaming video recognition. It's all about prepackaged capabilities to understand and interact in a human way. So that's why I think communication service providers need to put that on their radar screen in terms of providing a better customer experience on top of making the networks better and automated. Because these are there and they will be leveraged by enterprises. It will become the norm, and there's no reason why communication service providers shouldn't do the same. That was what part of my takeaways. I think I'm almost near the end of. This is another chart that reflects survey data, again, of the enterprises in their journey down the road. And I asked the enterprises, what are the top AI technologies and machine learning technologies you're using now? And what do you think you're going to be doing in 2020? And you can see that there were a whole list, but the ones that came to the top, as you can see, voice, image, augmented virtual reality, facial recognition, sentiment detection are the ones that are at the top. But don't ignore those in looking at AI and ML and what they can do for the communication service provider. The enterprises are there for a reason. And the augmented virtual reality is actually quite an interesting one. And you can see how the growth is expected. Now, they may be a bit optimistic in how fast they go, but still the challenge is there. What else? Yes. And so we forecast. We have a model. Well, this is actual. This is forecast. And my message here is, coming back to what I said a few times through this talk, computation will occur in multiple places. This is the number of servers shipped in 2017, 10.6 million, where 4.8 million were on the enterprise prem. Then we have service provider communications, service provider cloud. The enterprises will be about flat in terms of total number of servers that they buy in 2022 compared to 2017, but that will represent about 32% of the market at that point. Whereas the communication service providers will grow, and so will the cloud service providers, and I believe we reach a new equilibrium. This is about where I think it's going to stay. My message here is that the on-premise data center for the enterprise, and I believe the communication service provider, is important, but it's only part of a larger ecosystem with the capability to rent compute as needed. And some people, had said, oh, it's all going to go to the cloud. There'll be no enterprise data centers. It's not true. This is about where we were predicting this is going to be a new equilibrium. So think about that again for the communication service providers as you go forward and set your strategy for where do you buy or where do you rent your compute. And AI and ML, how fast? How far? Well, our actual numbers show that about 2% of servers shipped in, this would be 2018 now, were equipped with a coprocessor, such as a GPU or an FPGA that was powerful enough to be used for AI and machine learning. We forecast that by 2022, that's going to be 15%. Well, that gives you some idea of how fast the transition or the adoption may go, because that's the silicon we will need to get the compute power for those kind of algorithms. And I will tell you that I don't have a breakdown here, but probably the majority of that 15% is in the cloud service provider data centers at that point because of the speed at which they're already deploying servers with this kind of capability. But I also believe that a growing proportion of this going forward will be in the central office of the communication service providers. And in fact, I think I said this yesterday afternoon, I've already had hinted at switch manufacturers, router vendors. Today, you'll find a switching chip in there, whether it's a Broadcom chip or one of the other merchants, or whether it's proprietary, and you'll find an x86 and it's typically running Linux, and all the rest is software. And I've said to them for a little while now, well, how long is it going to take before I see some sort of GPU in there and you're going to be able to do some sort of co-processing on the telemetry you collect right on the spot? And they just smiled at me and they wouldn't tell me. But they didn't tell me that doesn't make sense. So just keep in mind that things will percolate into other devices as well. Where can we borrow? What are ideas for adoption of AI and ML? Well, we all talked about analyzing performance data. That's an obvious one. By the way, this is parallel to things I'm seeing in the enterprise, in the energy sector. This is parallel to analyzing rock formations. Predictive troubleshooting, a lot of work going on in the enterprise sectors for that. I heard a lot about that here today. Heard a lot about the concept of creating digital twins, where you can run simulations on equipment in the cloud to try to understand what's going on in the real piece of equipment. I think that's going to be an important application for communication service providers. This technology is already there in many other places. Drones and robotics, inspection of remote sites, that's already planned in the oil patch to look at remote oil rigs. I think the same thing will apply for inspection of remote offices. It won't always be a truck roll. Voice assistance. So like I said, survey was a little too low in my opinion on using, on the customer interaction side, AI and ML. So voice assistance. OSS, BSS onboarding, we talked about that. One of the things that other sectors have used is the large bodies of knowledge that are in text. And there already are recognizers that can read the text, understand it, create a catalog of all the information contained in there, and then when an engineer is looking for a piece of data or some bit of knowledge, they can use voice and say, I'm looking for this study that covers this. And instead of spending days looking for in the library with books, out it comes. So there's already systems that do that for other sectors. And the last one I wanted to talk about was I saw a company, it's a small company, that had been applying the same similar technique to understand documents to legal contracts. So the legal contracts scanned, understood, the relationship between the parties in the legal contracts cataloged, and then through monitoring telemetry, the actual billing and settlement charges are reconciled automatically. So the human is taken out of the equation. It turns out that the company claims they have found millions of dollars in false charging, not by error, just people make mistakes. And they've saved many millions of dollars for the companies that have been using this. So here's another area where this type of technology could apply that maybe we didn't think about that we should. Okay, and I think I've just got a set of conclusions and I'm already out of time. So I think we all agree automation's imperative. We're not going to get where we need to get to without it. Multi-cloud ecosystem. My main message here is think about the communication servers, multi-cloud for your IT. And last but not least, I still think AI and ML for the next 5 years is cloud-led, but it doesn't mean that communication service providers can't leverage it. So with that, I'm going to stop. Hope I didn't give you too many equations, and hopefully it was simple and understandable.
Okay, questions for Cliff? Maria.
Thank you. Thank you very much for your presentation. I have a question about your views and understanding on the demand for edge cloud compute. And in particular, I'm sure you've heard the emerging, if you like, debate around industry about operator provided edge cloud compute infrastructure for both, in the context of 5G, of course, it's very relevant, but I believe is equally relevant to fixed networks as well. So there is a lot of debate about whether gaming providers, for instance, are interested in loading their games into the operators' networks to ensure that the latency and the quality of experience is appropriate. Obviously, you've mentioned drones there as well, and again, there might be another use case for drone automation or if you like, a drone control to be based on the network. So do you have any insights into what the demand, the real demand out there is for that?
I can do better than that. I can actually send you a study we did. Late last year, I worked with Michael Howard, and he presented at the Open Network Summit in last October. We interviewed 14 of the thought leaders working in edge compute, telcos, mostly telcos. And we asked what were the apps for money, what was the timeline, and what were the difficulties and challenges in infrastructure needing to be overcome. So the top applications included gaming, but they also were centered on the immersive video experience. Could be in a stadium, 360 video came to the top. Autonomous vehicles were largely talked about. And another area was industrial IoT. that were talked about. So I can send you the study if you want to pass me an email address after, and I can send it to share it with anybody that would like that. And so I think that would help a lot in the insights. Now, the current thing that I've been working on with my team is we've just come up with what we think is a working definition for edges. So communication service provider edge, enterprise edge, and believe it or not, cloud service provider edge. They have edges as well. Much of their compute is actually in an Equinox data center, which is less than 20 milliseconds from the end user. And so we have working definitions, and now the next job for us is to take our compute research and figure out how is that distributed. So how much is at the edge now? Where do we think that's going to be in 5 years from now? So you can stay tuned on that one. I don't have a number for you.
Thank you.
Yeah, so I have one question here. When we talking to the service provider and all that, and then you see the machine learning and AI, and mostly, those are very specific, solve for one specific problem. So there is the question is the cost, to the training. It costs a lot of compute resource, and you need to spend a lot of money to get the training. And sometimes say the benefit you bring in for that particular case and versus the money I have to spend for the training, sometimes it's not a good trade-off for them. Do you have any insight from that angle?
Well, certainly without a business case, nothing will go forward. I think it was the gentleman behind you that was talking about herding the cats yesterday in our panel session. And, if the food isn't there, they're not going to go. I haven't myself personally built any business cases for it. However, we do see the activity in the enterprise, and they are seeing it. I believe the same thing will parallel for the communication service providers. And I think that you have to look at leveraging the knowledge you're building in terms of using the technology across a multiple set of problems. If you just apply it to one, you can easily kill the business case.
Thank you.